Hello students, in this session we are going to discuss another reagent. The next reagent that we are going to discuss is DDQ. So DDQ is 2,3-dichloro 5,6-dicyano 1,4-benzoquinone 1,4-benzoquinone. The structure of DDQ is like this. It's a quinone, that means double bond O, double bond O, okay, 2,3-dichloro. In second and third position there will be two chloro groups, 5,6-dicyano, 1 2 3 4 5, right? So this is what, so this is 2,3-dichloro 5,6-dicyano 1,4-benzoquinone 1,4-benzoquinone. DDQ is very reactive and it may be used in the cases where the substance is difficult to dehydrogenate. So quinones are generally used for dehydrogenation. Dehydrogenation, it is removal of hydrogen, okay, from the substances which are difficult to dehydrogenate. Quinones, they are used for dehydrogenation, and after dehydrogenation they get reduced to their corresponding hydroquinones. Okay, there are two important quinones that we use. One is DDQ, that is what we are going to discuss. Another, chloronil. The only difference is in chloronil, instead of cyanide there will be two chloro groups here, that's what. But DDQ is there for a syllabus, so we'll be discussing DDQ only. Okay, let us discuss the preparation of DDQ, how DDQ is prepared. So DDQ can be prepared from quinone, double bond O, double bond O. So this is the starting material that is used in preparation of DDQ. So we need to substitute cyanide groups as well as chloro groups here. So this molecule is treated with hydrogen cyanide in presence of methanol and H plus. What happens is the double bond O gets converted to OH, aromatization takes place, and cyanide group gets substituted here. Okay, so this is what happens when we treat it with hydrogen cyanide. So double bond O gets converted to OH, okay, aromatization takes place, and cyanide group. Okay, this is what happens. This is subjected to oxidation. Oxidation is removal of hydrogen or addition of oxygen. So on oxidation, so removal of hydrogen takes place and you get back that quinone skeleton. That means double bond O, double bond O, CN, CN. So half work is done here. So now only we need to attach Cl groups. Okay, now, so this molecule, whatever that we have obtained, is treated with HCl. Molecule is treated with HCl. When it is treated with HCl, so what happens? Okay, when it is treated with HCl, again double bond O gets converted to OH. We have cyanide here, aromatization, and then Cl gets attached here. Again it is subjected to oxidation. Again you will get back that quinone skeletal. Cn, the Cl is attached here. That's what I get. So we have attached two Cn groups as well as one Cl. So we need to attach another Cl. So again this is treated with HCl. It is treated with HCl. Again same thing happens. Double bond O gets converted to OH. Okay. Cn, Cn, Cl, Cl. So then what we want? We want back the quinone structure. Again it is subjected to oxidation. So it is subjected to oxidation. What happens? Double bond O, Cn, Cn. This is what is done. Okay. So this is the first carbon, double bond O. Numbering starts from functional group carbon. So this is the ketone. This is the first carbon. Next this is the second carbon. Because if there are substituents, then substituents are named in the alphabetical order. So chloro starts from C, cyano also starts from C. If both are C, you should go for the next alphabet. It is CH and it is CY. So here the second position, first numbering, second, third, fourth, fifth, sixth. So it will be 2, 3 dichloro, 5, 6 dicyano, 1, 4 benzoquinone. It doesn't matter whether you write Cl this side or this side. So because the numbering will be starting from the functional group carbon, and next we will move on with the carbon that contains that is attached to which the chlorine group is attached. So this is the preparation. Simple is to start with quinone. We want cyanide groups, so treat it with HCl. Then we want chloro group, treat it with HCl. For each step you should carry out oxidation, because when hydrogen cyanide attacks, so aromatization takes place, double bond O gets converted to OH. It gets converted to corresponding quinols or hydroquinones. Phenolic structure comes here. So you get aromatization here. So double bond O gets converted to OH groups. So again you should carry out oxidation, so that you will get back the quinone ring system. Okay. So this is the preparation of DDQ. Now what is the use of this DDQ? DDQ is generally used in dehydrogenation, that is removal of hydrogen. Okay. So DDQ is an effective reagent for dehydrogenation. The best example is tetraline. Tetraline, when it is treated with DDQ, okay, in boiling benzene, DDQ converts tetraline into naphthalene. Okay, let us deal with that example so that we'll have a clear idea regarding that. Right now, see, let us see what is this tetraline. Okay, I can call that as, because aromatization takes place, so I can call it as aromatization of tetraline is what I can call it as. Aromatization of tetraline. So tetraline is also referred as tetrahydronaphthalene. Tetrahydronaphthalene. So this is the structure of tetraline. Two ring will be fused. This is tetraline. Okay. Now, when tetraline is treated with DDQ, in presence of benzene and reflux means boiling benzene. Okay, when you heat it, okay, when you boil it, we call it as refluxing. So what happens is dehydrogenation takes place. Okay, and hydrogen from here and hydrogen from here goes off, resulting in the formation of a double bond here. Then and hydrogen from here and hydrogen from here goes off, resulting in the formation of a double bond here. So it results in the formation of this compound. Okay. you get this is what happens. So aromatization takes place. Generally what happens? Aromatization takes place. So that's why we call it as aromatization of tetraline to naphthalene. This is naphthalene. Okay. So what is actually happening? Dehydrogenation is taking place. Removal of hydrogen is taking place from here. A double bond is formed here. Removal of hydrogen takes place here, and a double bond is formed here. Okay. So let us deal with the mechanism of this. See, there is another reaction. Okay, before dealing with the mechanism, and there is another one. DDQ also oxidizes benzylic or allylic alkyl group to carbonyl group. Okay, so benzylic oxidation by DDQ in aqueous acetic acid takes place, and it proceeds via an intermediate. It is benzylic acetate. Okay, which is later hydrolyzed under the reaction conditions. Okay, see, tetraline, the same tetraline, when it is treated with DDQ, when it is treated with DDQ in aqueous acetic acid, okay, acetic acid CH3COH or else CHOH, that is aqueous acetic acid. What happens is benzylic oxidation takes place. Benzylic, I mean the benzylic carbon gets oxidized. Okay, so you get this compound. You call this as tetralone. Because it is a ketone, we call this as a tetralone. So the two applications of DDQ is, one is dehydrogenation, other one is benzylic oxidation. Okay, oxidation of benzylic and allylic groups. Even allylic groups also get oxidized. Okay, now so let us see the mechanism of this DDQ. I mean how actually the DDQ works, how tetraline gets converted to naphthalene is what we are going to discuss. Okay, now as mechanism. Mechanism is part is what we are going to discuss. Now I will first write tetraline. Tetraline when it is treated with DDQ. Okay, Cl Cl CnCn. Okay, so each carbon has two hydrogen atoms here. I'll just write an hydrogen atom here. See what happens. Right now, so the mechanism of dehydrogenation of DDQ involves transfer of hydride ion. It involves the transfer of hydride ion from an hydrocarbon to a quinone oxygen. It involves the transfer of hydride ion H minus to quinone oxygen. So when H minus goes off, a positive charge will be generated here, and loss of hydrogen takes place here, and it results in the formation of a double bond. This is what happens. Are we getting this? Right now, so loss of hydrogen, hydride ion. Okay, hydride ion moves off, resulting in the formation of a positive charge. So let us see the mechanism, what actually happens. Okay, so an hydride shift takes place. I mean hydride shifts to the OH oxygen, that is quinone oxygen. So when H minus goes here, this a new bond is formed, hence this double bond moves here, this double bond moves here, and this double bond moves here. Okay, see, resulting in the formation of this compound. We have a benzene ring type of structure, a benzene ring. Then we have this, right? Okay, we have this where an hydride shift has taken place, hence this carbon carries a positive charge. Okay, now here also we have one hydrogen. Here adjacent also we have two hydrogens, because each carbon has two hydrogens. Here I'll just write the hydrogens. See, this hydrogen has gone, so H minus has moved here, so this carbon will acquire a positive charge. Okay, plus let's see what happens to this DDQ. See, so you get OH here, double bond has moved here, this double bond moves here, the double bond gets O minus is what you're going to get. Okay, so the remaining as it is Cl Cl Cn Cn is what happens, right? Now, so then a loss of proton takes place here, and this proton forms OH here. Okay, because there is a positive charge, so hence what happens is loss of protons takes place and the electron moves here and forms a bond. So you get this is what you are going to get. Plus right, this is what you get. Okay, in the first step, dehydrogenation. Similar, the dehydrogenation takes place from this carbon. Okay, and resulting in the formation of a double bond. Let us go for that also. So this is the step 1 is what I will call it as. Step 2, what happens is here again this molecule, this one reacts with another DDQ, another molecule of DD2. So here there will be hydrogens. Here also there are two hydrogens. So an hydride shift takes place. So this carbon will carry a positive charge, right? Then a new bond is formed. Sorry, there is a double bond, already double bond here, hydroquinone. So this shifts here, this shifts here, and this will shift here, resulting in formation of this. Right? So this carbon will carry a positive charge. Right? So there are two hydrogens here. Okay. This is OH. Okay. Now this is what happens. Next, loss of proton takes place. Okay. OH, OH, Cl, Cl, Cn, Cn. What you get is you get naphthalene. So look at this. So this can be referred as aromatization. So actually what has happened? Dehydrogenation has taken place twice. Okay. So dehydrogenation is taken place, resulting in the formation of double bond. Here also there is dehydrogenation taking place, resulting in the formation of double bond. Hence tetraline can be converted into naphthalene by using DDQ. Okay, students. So this is the use of DDQ in dehydrogenation. One is aromatization of tetraline, and another one is that oxidation of benzylic and allylic groups, whereas a tetraline gets converted into tetralone in presence of DDQ and aqueous acetic acid. Okay. Thank you.